welcome you guys reaching out to me there. Also, ideally though, if you have a question about networking technologies or Cisco certifications, I would actually prefer that you use INE's online community. It's basically a blog that we have where people can post their questions. Your questions can be seen by thousands of other people, and then you can get a very quick answer. And in that way, other people can also benefit by seeing the question that you posted and the answer that you received. Now, in the event that you're not familiar with our INE online community, just let me show you where it is really quickly. You don't have to purchase anything from INE to have access to it. All you need is a free INE account. So if you don't have an INE account, just go to INE.com, click on like create account. No credit card or anything like that is necessary, just your name and email address, and then you can get access to our INE online community. And let me just show you what that looks like. I will bring it over here. So first you would just go to INE.com. This is assuming that you don't already have an account. And up here on the right where it says login, you would just click on that. And if you don't already have an account, you would create one, and then you would log in, and that'll take you into what we call our members dashboard. And like I said, this is free, nothing you need to provide to be able to get access to this. And then from here, in the upper right-hand corner, where you see where it says connect, that's what I want you to click on. That's where it says IEOC. That's the INE online community. And from there, if you click on that, you'll see we've got lots of different blogs, but as far as it pertains to this course, Introduction to Networking Technologies, if you have any questions about something related to that, I would probably recommend that you go under the Cisco category and click on Cisco CCNA. And then from there, click on the second one down, which is CCNA, and then just post your question right there. That's the most beneficial for other people as well as yourself. You'll get a much more quick answer that way, and other people will be able to benefit by seeing your question and answer if you post it right there. So I'm going to go ahead and minimize that because we don't need that on the screen anymore. So let's talk a little bit about the show today and what we're going to be covering. So my course objectives. So you can read these right here. So here's sort of my picture of the ideal learner for our session today. So my ideal learner is somebody who really has no networking knowledge at all. You know, you're a person who, you know how to use a laptop or a PC to browse the internet, get to your Gmail or, whatever you use. And you know that you have to connect to the network to be able to really do anything. But as far as your understanding of what the network is, that's really just limited to, okay, I see a cable here in the side of my laptop. I need to plug that in, and then I should connect to the network. Or maybe I'm using something called Wi-Fi. I don't really know what Wi-Fi is, but I know that my Wi-Fi has to be turned on, and then somehow I magically connect to the network. And what you're really wondering is, what is this thing called networking? What is the network? What is this thing I'm connected to? I'd like a real sort of high 60,000 foot view on what is networking, because maybe that's something that would interest me. Maybe I'd like to make a career change into the field of networking, but I don't know anything about it. And I'd like to learn just the basic core fundamentals of it. So that's what we're going to be talking about today. So that is our course objective. So this is, if you actually are studying for a certification in networking, specifically if you're studying for like a Cisco certification, what I'm going to talk to you about here today is stuff that you would find in like the CCENT, the Cisco Certified Entry-Level Technician, or the ICND-1 certification, or possibly the Network Plus certification. So this is that sort of low-level stuff that you would find there in the first 2 or 3 chapters of a book for those particular things. So what are we going to cover? So these are the things we're going to cover. And at the end of each section, I'm going to have a break where I'm going to reach out and see if you guys have any questions and answers. I know you're all watching on YouTube Live right now, which is awesome. And by all means, as I'm talking here, feel free to type in your question. Just be aware that because there's so many of you and I have stuff to cover here, I don't really have the ability to look at your questions as I'm going along with my slides. So what I'm going to do is I'm going to have my slides broken down to these little sections here, and at the end of every section, 20 minutes or so, then I'll go to your questions and see if there's any unanswered questions. But by all means, feel free to type in any questions you have right now. There's a lot of people watching, and many people will probably be able to answer your question even if I can't get to it until my Q&A time. Okay, but there will be several breaks for questions and answers as we go through today. So I'll start just by answering the question, what is a computer network, at a basic level? What are some of the components of a computer network? What, at a real high level, makes these things work and connect together? What are some of the technologies that comprise a computer network? And utilizing those technologies, how can we formulate that into a job role? What's the difference between a network admin versus a network engineer versus a network architect? You may have heard those terms. What does it really mean? What does it mean from a job perspective? Then I'll talk a little bit about computer networking job specialties. If you get hired into a really large company that has a really large network, you might be privileged to be able to work in a very specialized section of the network, doing very specialized tasks. And we'll talk about what some of those things are. Or maybe that's your long-term objective, is to move into a role like that. And then lastly, where do you go from here after this particular session is done? So what prerequisites do we have for today? Well, really, zero. There's, as long as you have eyes to see and ears to hear and you're able to watch me on the computer, you're good to go. So this is real ground level stuff here we're going to be talking about today. Like I mentioned, there's going to be Q&A sort of peppered throughout the presentation. And I've already given you my contact information, so you have that. So with that, I'd like to go ahead and go into the first section here, which I have titled, What is a Computer Network? And we're going to pretty much answer three different things. What are the parts of a common computer network? What's some common vocabulary, terms that you might hear bantered about and you want to know what those terms mean so you're not ignorant when people are talking about networking? And then lastly, why do we need computer networks? We'll actually probably start with that one. So let's start with the concept of what is a computer network, this thing you're plugging into. A lot of times people, when they envision computer networks, they envision these monstrously large things with lots of devices, lots of blinking lights, a lot of cables snaking through crawl spaces and ceilings and floors, and it just seems horribly complex. Well, a network certainly can be like that, but in its simplest terms, a network is simply defined as some mechanism that allows two or more computing devices to exchange information. That's it. For example, you could have a laptop sitting on a desk, another laptop sitting right next to it, and a simple cable between them connecting them, and you've got a computer network. It can be as simple as that. And then, of course, it can scale and grow from there. So let's talk about some of these components right here. So initially, when networking, first came out a good 40 years ago or so, what it looked like in the very early days was that you had, now this is even before laptops and PCs existed, okay? So this back in the days when you would go into a room that was super cooled with an industrial air conditioner. It had a monstrously large, IBM mainframe in it. You sat at a dumb terminal that connected that mainframe to type in characters and things, and you needed a network so that mainframe number one could talk to mainframe number two that was just 20 feet away from that mainframe. So in those real early days, a network simply physically consisted of one cable that these devices would tap into or clamp onto. So the devices, so we would have three components. Number one, the device that connected to the network would have to have specialized networking software. A device needs to know that it's connected to a network. It needs to know, okay, how do I send information onto the network? How do I receive information from the network? The device needs to know, okay, this particular application I'm running needs a network to run. This application I'm running does not need a network to run. So it needs some sort of networking component to the software running within that computer. So that's number one. Networking software is required. Number two, the device need to have some sort of physical connector to the network. And we'll look at that coming up here in just a second. That's called a network interface card. That's the physical component of that, in those days, mainframe that tapped into or clamped onto the cable. That was our network interface card. And then number 3, we had to have some sort of medium to transfer our information, which back then was a copper cable. So then things progressed a little bit. PCs started coming out, and so we have this picture of what we see right here. So in the early days, you would have one wire going through, and each person's PC would be tapped into that wire, and so they would all be able to talk to each other. So here we've got an example of 2 networks. We've got Department A's network, and we have Department B's network, and they're tapped into it. And then as networks evolved, people said, hey, why don't we use the same wire that we're connected to, not only to send and receive our data, like our emails and our web browsing, let's also use it for maybe voice. So let's take our telephones and convert them into networking capable telephones and connect them. And then networks evolved again. People said, well, if everybody in our building is connected to one physical wire, that gets kind of congested. That means, everybody can hear everything, they can see everything, there's really no security. The network's getting kind of overloaded because we're all sharing one wire. And so some people said, hey, let's invent a device that can take this building and split it up into different networks. And so a switch was created. Actually, a bridge was created before that. So you don't have to know that term right now, but just know that networking then evolved to where instead of each person connected to one physical wire that was like 100 feet long and everybody tapping into it, now networks evolved to where every PC had its own individual cable, its own individual wire. And that one wire went from your computer directly to this central device, which, as we see here, is the bridge or the switch. And so that worked just great for a while. And then networks evolved again. And then wireless networking came out. And so that's what we see right here. So with wireless networking now, your network interface card on your laptop or PC no longer connects to a physical cable. Now it transmits into the wire. It transmits into the air, like a radio transmits and receives into the air. Basically, that's what wireless networking is. You have a radio inside of your tablet or PC or smartphone that's capable of not only receiving like a normal radio does, but it's also capable of transmitting. We actually call it a transceiver for transmitting, receiving, transceiver. So every Wi-Fi capable device, whether it be a smartphone or a tablet or PC, has a transceiver inside of it. And so that's what you see right here. So here there's a transceiver inside of this laptop or PC right here, and it's using the airways, which are then being picked up by these antennas that are sticking out of these, what we call access points. So when you go into a building or go in your house and you look up on the ceiling and you see those things sticking out of the ceiling with blinking lights on them, and I'm not talking about the fire escapes or the exit signs, I'm talking about what's called an access point. Typically in any building you'll see an access point, roughly every 50 or 60 feet along a hall or in different building or in different rooms. And so your wireless networking on your laptop is talking to that access point that's sitting on the ceiling. Now the access point in turn has a cable. You probably can't see that cable. It's probably behind the ceiling or behind the wall or something like that. And that cable then connects it up to what we call the network infrastructure. So that term network infrastructure basically means all the components beyond your laptop. So the network infrastructure would be the cable leading from your laptop and then all the different devices between you and the other laptop or the other server that you're trying to talk to. That's what we call the network infrastructure. And it can be as small as one device, like in this case, a network infrastructure is simply this one switch and a whole bunch of cables. Or if you're talking about a really large corporate network, it could be hundreds or sometimes even thousands of devices making up the network infrastructure. And so then, of course, we have to tie in our wireless network to our wired network. If we want to implement some security, we want to keep certain parts of the network isolated from each other. Or maybe we have a need where, okay, the people in the wireless network, we only want them to be able to access certain resources in the wired network. Not everything, but only certain things. So then we would probably implement a router. And that's what we have right here. This hockey puck-like icon right here is a router. And a router is typically used for really two purposes. Number one, when you need to connect networks together that use different types of cables or different types of networking medium, you would typically use a router for that. Routers have many different kinds of NIC cards. So it can have, for example, a NIC card that supports a fiber optic cable, which is like a very thin strand of glass or plastic that's carrying laser light signals. And it could have another NIC card of that same router that's connecting to a copper cable. So that's one reason we use routers, is to connect to different kinds of networks. Another reason we use routers is to implement security, give ourselves very fine-tuned control over what parts of the network can communicate with other parts of the network. And then if we build onto our topology right here, as our network grows and grows, you know, it might have started. When you started with your network when it was really small, chances are that your laptop was communicating to a server. A server is a device that's holding the information you're trying to get. For example, when you go to email, right? When you go to Google or whatever email that you try to get to, well, your laptop is considered a client, and Google owns thousands of these big computers called servers, which are storing all of your emails. So that's a client-server architecture. As a matter of fact, most of what you do when you connect to networking is client-server based, where you are the client and you're going out to a server that's hosting a website and you're trying to pull the website down, or you're trying to pull down an email, or you're trying to pull down a musical file, something like that. Well, back in the early days of networking, the client and the server were probably located on the same floor, maybe even the same cube or in the same office as you. So, you know, payroll, which took up this corner of the floor, might have 3 or 4 of their own servers that they were tapped into via networking. In another corner of the same floor of the same building was human resources. They had their own servers. And then people started recognizing, with having all these different servers maintained and owned by different departments, it's really difficult when things go down to troubleshoot what went down, where it is, where's the server that went down. And people started realizing it'd be a lot easier from an implementation and a troubleshooting point of view to take all of our servers and locate them in one central place. So instead of having them spread out across the building where you don't know where they are and you don't know what part of the network is used to reach them, let's take them and all put them in a secure room with a lot of air conditioning that we call a data center. So that's what a data center is. It's a big room with a lot of electricity running in it that's housing all of your servers, all the information, your mission critical information that your people need to get to. So clearly that would also need to connect to the network. And then of course, we can't forget the last component of this. Most networks these days also need to have some sort of connectivity to the internet. So they'll use an internet service provider like Spectrum or Time Warner Cable or whoever your internet service provider is. So your network will need to physically connect to that as well. So those are the components, and we'll drill into some of these in a little bit more detail as far as what a computer network is. So let's look at some vocabulary surrounding this. LAN versus WAN. So a LAN stands for a local area network. Local area network. Well, what does that mean? A local area network is usually defined as a network that's, small in scope. In other words, one end of the network to the far end of the network is maybe at the most a quarter of a mile long. But in a lot of local area networks, it's just confined to like a room in a building or maybe the building itself. But if you are working on a local area network, that means that local area network and everything that makes it up, the cabling, the NIC cards, the routers and switches, all the components of that local area network are owned, managed by you, by your company. Your company bought all that stuff, installed all that stuff. It's all under your control. And the networking software, the networking rules and protocols that operate on that local area network assume that things are fairly close together, right? That things are maybe anywhere from 5 feet to maybe 500 feet apart from each other, but not too far apart. So that's a local area network, as opposed to a wide area network. For example, if I have an office in Boise, Idaho, and that office needs to send and receive data to another office in Miami, Florida, well, clearly, I don't have the financial resources, nor do I even have the government authority to run a cable 3,000 miles from Boise, Idaho down to Miami, Florida. And even if I was infinitely rich, and let's say I could actually afford to run a cable under the ground for 3,000 miles, do you think that the government would allow me to dig that trench and go that long? No, they wouldn't. So we need some sort of network that's going to connect things that are wide apart in distance, that are far apart from each other. And that is a wide area network. So when you connect to Sprint or Time Warner Cable or Spectrum or AT&T, something like that, they own the wide area network. They've got the cables that are running for thousands of miles across the country, across the oceans, and you are sort of leasing or renting time on that network. So a wide area network is something that spans vast distances. A local area network is something that's completely in your control, that's fairly small in its geographical scope. Another term you should be familiar with is something called a node or a host. So I mentioned that the network infrastructure is a term for all the cabling and all the devices in the middle that transmit the information back and forth. Well, a node or a host is just a generic term for anything, any endpoint that connects to the network. So for example, your laptop, your PC is a node or a host on the network. Your smartphone, if your smartphone is connected to a Wi-Fi network, that is a node or a host. Your tablet is a node or a host. Any end device is connecting to the network for the purposes of either pushing data into the network or retrieving data from the network is called a node or a host. Local versus remote resources. What's that? Well, think about your laptop for a second. Think about if your laptop had no network connectivity at all, no Wi-Fi connectivity, nothing. What are some of the things you could still do with your laptop? Well, you still have a hard drive on your laptop, so you could still create spreadsheets and Word documents. You could still use some sort of bitmap editor to draw things. Those are all local resources. Those are things that are local to you that don't require a network to run, to be able to allow you to do something. Your monitor, that's a local resource. Your keyboard, your mouse, that's a local resource. Now, what's a remote resource? Well, a remote resource is just the opposite of that. A remote resource is something you're using that's only reachable across the network. For example, if you are printing to a Wi-Fi printer, you don't have a physical cable to the printer is in the next room and it's available via Wi-Fi. That is a remote resource. You're trying to pull down a website. Well, that server is only reachable across the network. It's not on your laptop. That is a remote resource. Sometimes you can access remote disk drives like remote optical drives and things like that. So basically anything that is only reachable if you have network connectivity is considered a remote resource. It's not local to you, it's remote. And then of course we have the internet. So what is the internet really? So in reality, the internet is just millions, probably even billions of local area networks all connected together. When you connect your laptop to your networking cable or to your Wi-Fi, you are now part of the internet. You are part of it. So the internet is really just Google's network, right? Google has a part of their local area network that connects to the internet. Google has a part of their network that has servers on it that dish up websites. There's another part of the internet, which is CNN's network, the cable news network. They got a bunch of servers They have websites and stuff with news. They make up the internet. All these millions and billions of companies that have servers connected together make up the internet. So the internet is like this giant spider web of all these different networks, all interconnected together, dishing up information, sending information, retrieving information. That's the internet. So I think it's probably pretty clear, if you're watching this show, the answer to the question, why do we need computer networks? You know, back in the early days, before there was networking, before there was cables and everything, if you had some information that you create on your PC, some spreadsheet or document or something, and you wanted Joe over there in the next room to have that same information, you had to use the sneaker net, like tennis shoes, like sneakers. What is the sneaker net? The sneaker net literally meant, okay, you took that information, you copied onto a floppy disk drive, which some of you guys might not even know what a floppy disk drive is a little card about this big that had a little circular magnetic thing in the middle of it that you could copy your information to, and then you walked it over to Bob and you said, Bob, here, put this in your disk drive, and then he could copy the information from you. So clearly there's long been a need to exchange information between computers. That's why we need computer networks. So computer networks allow us to share three main things. Files, right? You can share your spreadsheets, you can share your documents with other people. Programs. For example, you could download an antivirus program across the network. You can download a program that allows you to create music videos over a network. Download a whole new operating system across a network. So we need a network to be able to get to those programs. And resources, right? We use the network to get to a shared fax machine or a shared printer, or maybe a shared network-capable video camera. So there's a whole variety of reasons why we need networks. So at this point, I'm going to pause for a second and take a look and just see if there are any unanswered Q&A that I could get into here. Does anybody have any questions for me? So here's a question coming in. Should a networking engineer study Linux? The answer to that is it depends. So a lot of it depends on what kind of company you're going to work for. I see a lot of, for example, if you went to work for Cisco Systems, let's say, and you actually worked internally in Cisco's IT staff, right? You're part of Cisco's own internal network. They are so large, like IBM is so large, like Microsoft is so large, that you could literally have a job that deals with nothing but Cisco routers and switches. You wouldn't have to know anything about Linux. You wouldn't have to know anything about servers because their network is so big, they need people just to support the networking infrastructure itself. Now, where Linux comes into play is a lot of other companies will have their network engineers or network admins double up as like a server admin as well. So their network is not large enough to provide full-time work every single week of the whole year. Most of the time the network is running, it's pretty small, nothing really happens on it. So they want somebody there who's capable of doing networking just in case something goes wrong, but your primary job is also to work on the servers and to set up email accounts and web accounts and stuff like that for people. So for that, Linux might be a very useful skill set to have. Somebody also asks, after the completion of getting a CCNA in routing and switching, what is the next thing to do? This is just my recommendation, but I typically recommend that people, after they get their CCNA in routing and switching, go and pursue a CCNP in routing and switching. Routing and switching is really the fundamental, the basis from which all other specialties of networking branch off from. And the CCNA, in my opinion, doesn't give you enough depth of knowledge for routing and switching to where you are ready to branch off into wireless or security or collaboration or data center. I think you need to get up to at least a CCNP level in routing and switching, and then at that point, you can make a decision. Do you want to go one more level and get your CCIE in routing and switching? Or at that point, you could branch off into like Wi-Fi or security or something else. But that would be my recommendation, to get a CCNP in routing and switching. Someone's asking, where is shell scripting used in networking? So if you are working on a really large network that changes fairly frequently, you might find yourself issuing the same sets of commands across multiple devices over and over and over again. For example, maybe part of your daily task when you get in the morning is that you log into one device, you issue like 6 or 7 commands, collect all the information from that, and then parse through it looking for certain output. And then you repeat that pattern across 75 or 100 devices. Shell scripting is where you can write something on your computer that will automatically log into all those devices, automatically issue the exact same commands across all of them, take all the feedback, and also parse through it and then print out a report for you of what you're looking for. So it's just a way of automating things that you would normally have to do manually. Somebody asks, is GNS3 free to use? Absolutely, but GNS3 also requires that you have a valid Cisco iOS image, which is not necessarily free to use, so you'll have to find that somewhere. Somebody says, is being dependent on just a single technology enough? Probably not in today's world. In today's world, there are a lot of people who have just routing and switching technology experience. Most employers are looking for routing and switching and at least something else, like routing and switching and security, or routing and switching and data center, something along those lines. What other questions do we have here? And I see some other people are responding to the question of GNS3. That looks great. Yeah, Salim, I would definitely agree that along with routing and switching, you definitely want to learn other things like Wireshark. I see Checkpoint is very popular. All right, so let's go ahead and continue on with the next section, and then I'll come back to the Q&A and we'll take it from there. So in this next section, we're just going to talk real briefly about the components of a typical computer network. We're going to dig a little bit more deeply into what are these things called servers and clients, what are some examples of local and remote resources, and what are some other common networking components. So we'll look at all that. Okay, so I briefly mentioned this term servers and clients in the last section. So now let's just talk a little bit more about that, in case you have not ever used that term before. Maybe all you think of is a computer. You don't really think in terms of servers and clients. Well, think about going to a restaurant, right? So when you go to a restaurant and you sit down at the table, you are the client, and what happens? Well, hopefully after a few minutes, a server comes to you. And what's the function of that server? The server is for you to make your request, say, hey, I want the hamburger, I want the hot dogs, I want the chocolate milkshake. So you tell the server what you want, and the server goes and gets it for you and then delivers it to you. So same type of thing in computer networking. A client is like your laptop, your tablet. It's presenting a request. It's saying, hey, I need this website. I need this music file. I need fill in the blank. I need something. So the client makes a request of the server. So the server is just another computer. It has memory. It has a hard drive. It has a keyboard just like your computer has. The only thing that really makes it different from your computer is the server has more of it. It has a lot more memory inside than your laptop has. It has a bigger brain, a bigger processor than your computer has, because a server is typically receiving requests from hundreds, if not thousands, or sometimes even millions of clients every single minute. And so it has to have a lot more resources to be able to respond to those requests. You could actually turn your laptop into a server, into a very crude, very basic server. It wouldn't be able to respond to too many requests because your laptop doesn't have all the memory and all the processing power that an actual server does, but it could perform that role. So a server and a client is really just a role that a node or host is playing in the network. I also already mentioned this in the last segment, some differences between local and remote resources. Some examples of local resources are your own hard disk drive, the memory, keyboard, and DVD-ROM drive on your laptop, on your tablet, whereas network resources, otherwise known as remote resources, are examples of networked hard disk drives. For example, if you are familiar with using Google Drive, or if you're familiar with using Dropbox, you are making use of a networked hard disk drive. In other words, when you go onto Google Drive or Dropbox and you put on there all your files, your photographs, your videos, where do you think those things are being stored? They're being stored on a hard disk, just like the hard disk you have on your laptop. The only difference is that hard disk, number one, isn't local to you. You have to get to it via a network. And number two, that hard disk is not managed by you. It's managed by Google or managed by Dropbox or whoever you're using. And number three, that hard disk drive you're getting to is much, 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 much bigger than the hard disk you have on your laptop, because it's storing so much more information than your laptop possibly could. So that is a networked hard disk drive. There are also networked printers. You guys are probably familiar with that. There's even networked optical drives that are connected to network servers. So one thing I also want to point out here is that you can't, just by physically looking at something, you can't necessarily tell if that thing you're looking at is a local or a remote resource. What do I mean by that? Okay, imagine that you're sitting at your desk and next to your laptop or your PC, you see a printer. Now looking at that printer, just by looking at the front of it, you can't tell if it's a local or remote resource. Now maybe you go around to the back of it and you say, aha, I see the printer has a special cable, a printer cable, and it's connected to the printer port on my PC. So that is a local resource. That's true. For you, for your PC, it is a local resource. But that very same printer could have a networking card in it. It could have a wireless card in it, and so it's also a remote resource for other people. Now, you can't connect to a network if you don't have a connector. If you don't have a network interface connector or a network interface card, you can't get on the network. And network interface cards, or NICs, come in various different form factors. So here what I'm showing you is probably the most common form factor you're going to see, which is what's called an Ethernet card or an Ethernet NIC. So if you take a look right here, this connector that you'll see all over the place, there's one right here, there's one right here, there's one right here. This, as it says, is called RJ45. You'll never need to know that, but RJ stands for registered jack. So there's actually a document that says a registered jack 45 is a certain size, has a certain quantity of pins in it, that defines how you build one of these things. So Ethernet networks connect typically to RJ45 jacks. You'll have an Ethernet wire which will connect to an Ethernet NIC card. Now the jack, or the port, is just the external part of the NIC card. It's just the part that you can see with your eyes. You know, behind here, if we took it out, this whole thing is the network interface card. So clearly the cable connects in right here, and this is an RJ45 jack, right? So if anybody ever says, hey, unplug the RJ45 jack or unplug the Ethernet connector, this is what they're talking about right here. So you just press down on that little tab right there and you can just pull it out of the RJ45 jack. But behind that, you've got all the circuitry and all of the intelligence for this thing to understand how it connects to the network. Because just because you plug in a cable doesn't answer some critical questions. The computer has to know, okay, well, how do I manipulate electricity on this cable so that the other end of the cable knows I'm actually transmitting information, not just garbage electrical energy that means nothing. How do I manipulate the energy in a way that represents a code that the other side knows what the code is and can reinterpret that as data? The NIC card knows how to do that. When electrical energy starts coming in, when the NIC card says, oh, I'm getting some electrical energy off the cable, how do I know if that's valid data? And how do I know if that's for me or for somebody else? The circuitry of the NIC card knows how to answer that question as well. So this whole thing here is the network interface card. Now, that's just one type of wired network you could connect to. Another type of wired network is called coaxial cable NICs. So for example, if you have a cable modem at home, you're connected to Time Warner Cable or Spectrum or something like that, and you're using a cable modem. Well, this is your cable modem, and you notice it has an RJ45 jack right here. So that's what will connect to the Ethernet NIC card on your laptop or PC. And then this part right here is what we call a coaxial connector. That connects to a different type of cable right here. And you can see the ends of this are different. It's still a copper cable. If I unwrap this plastic or rubber on the outside, I'll still find copper on the inside, but there are some key differences. For example, in an Ethernet NIC card, an Ethernet cable, if I unwrap the copper on the outside, I would actually find multiple strands of copper on the inside, not just one. There'd be many strands of copper in here. Whereas in a coaxial cable, there's really just one thick copper wire underneath here. So when you're connecting to cable networks, you're going to be using a coaxial cable to do that. And so you'll have to connect, so right here, we don't see it, but there is a coaxial NIC card in here. This is the outer side, right? This is the connector. But behind here inside the cable modem, there's circuitry to understand how do we transmit information on a coaxial cable? What is valid electricity? What's not valid electricity? All that's in there in the NIC card. There's also wireless NICs or Wi-Fi NICs. And by the way, contrary to some popular belief, Wi-Fi is not an acronym for something. Some people used to think that Wi-Fi stood for wireless fidelity. Nope, doesn't stand for that. It doesn't stand for really anything. It's just Wi-Fi. It's just a trademark. So in a Wi-Fi NIC, you're going to have the outside that you can see, if you can see anything, will probably be an antenna like this. So in a Wi-Fi NIC, you have to have an antenna. The antenna is the thing that takes, so the internal energy of your laptop or PC or your tablet comes to the Wi-Fi NIC internally as electricity. So there's electrical voltage, sort of like when you stick a battery on your tongue and it shocks you. Think of that electrical energy inside your tablet, inside your smartphone, going to the Wi-Fi NIC card. At that point, the Wi-Fi NIC card puts it on the antenna, and the antenna radiates it into the air as radio frequencies. So it changes it from electrical energy on a wire into radio frequencies into the air. So Wi-Fi NIC cards have to have an antenna. Now you might be thinking, well, wait a second, Keith. I'm looking at my smartphone. I'm looking at my iPad here. I don't see any antenna on that thing. Well, just because you don't see it doesn't mean it exists. You ever driven in a car and you couldn't visibly see where the antenna was on the car? Right? A lot of cars these days, You don't see the antenna. It's not like the old days where the antenna was sticking up and flapping around and got caught in tree branches, right? A lot of cars these days, you don't see the antenna, but clearly it has one. Otherwise, your radio wouldn't work. That's because in a lot of devices, the antenna is built into the chassis or the exterior housing of the device. And the same is true with networking devices. For example, this tablet right here, somewhere probably on the long edge is one or possibly two antennas built into this thing. Otherwise, it would have no Wi-Fi connectivity whatsoever. Same thing here. Here's a picture of, this is actually Nexus 7 tablet that was sort of split open, and the antenna is right there. It's on the inside of it. And then the rest of the Wi-Fi NIC card has a radio in it. Some portion of this is going to be our transceiver, capable of transmitting and receiving. So our transceiver is going to be in there as well to give us Wi-Fi connectivity. So those are the most common types of network interface cards you'll see on host devices. You know, Ethernet NIC cards and Wi-Fi NIC cards are by far the most prevalent that you're going to find. Now, so what do those connect to? So you got a wire coming into, let's draw this right here. So here's my laptop, and let's say I have a NIC card, a network interface card right here that has an Ethernet cable. So here's Ethernet. What's it connect to on the other side? Or if I'm talking wireless, right? Here's my laptop right here, transmitting wired. Where does that go to? What picks that up? So now we're going to start looking at the network infrastructure, the other end of the cable. Where's that cable terminating? So if it's a wire, if it's a physical cable, most likely it's terminating in what we call a switch. So as you can see, a switch is a device that has at minimum 8 or possibly hundreds of these RJ45 jacks. So if you go into an office and you look on the side of the wall and you see on the side of the wall, you see a wall plate. Looks like this. And the wall plate has several RJ45 jacks in it. And usually they're color-coded. One might be white, one might be green, one might be red. Well, all those RJ45 jacks connect back to a switch somewhere. So the switch is the central point where all these cables merge and connect into that. So that is our first networking device. And switches can run, as you can see here, in form factor. They can be really, really small and really inexpensive. Like this Netgear switch right here is probably something like $50, 50 US dollars to buy that. Whereas this switch right here could easily cost you $450,000 to buy that. So it just depends on what your needs are and how big and how complex they have to be. Now, in addition to switches, right? Switches will give you your basic network connectivity, and a network can be composed purely of nothing but switches. Switches and cables can be everything there is in a network. A lot of times people will say, well, I have different types of networks that need to connect. Now, I have one network that's using fiber optic technology, another network that's using copper cables. I need something other than a switch to do that. Or I need to implement some security and other types of features in my network that gives me more control over where the data is going, the paths that data is selecting to use, where stuff can go, and I want more control over that. Well, that's where people would typically buy a router. Now, this particular router right here, you can't really tell. I mean, it looks like all these interfaces are RJ45 jacks, and they very well could be. But RJ45 isn't just used for Ethernet. Just because a jack looks like this, I'll draw it a little bit. So just because that's the exterior of a jack does not necessarily mean that that is only going to be used for Ethernet networking. Ethernet is one set of rules, one set of protocols for accessing networks. There are other sets of rules, other sets of protocols that also just happen to use the exact same type of jack, RJ45. So it's entirely possible that some of these jacks on this router are being used for Ethernet, and some of these jacks are being used for other types of features, other types of protocols as well. Or if you need to connect your local area network to a wide area network, Many times you'll use a router for that as well. Routers are optimized for those types of things. And then I already mentioned this, Wi-Fi access points. So your wireless NIC card and your tablet, your PC, your laptop, it's talking to a Wi-Fi access point. A lot of Wi-Fi access points you might not even be able to see. They might be on the other side of the wall panel or the other side of the roof infrastructure, and so they're invisible to you. And then the Wi-Fi access point, so it's receiving wireless radio energy from your laptop, and then it in turn has a cable, which will most likely go back to a switch. So you're not going to see the switch, you're not going to see the cable, but you probably will see the Wi-Fi access point somewhere on the wall or on the ceiling somewhere. So those are some of the real basic common components of your typical stripped down sort of bare bones networking. So with that, once again, I'd like to take a break here and see if there are any questions and answers that I could help with. So let's go back to the YouTube stream here and see. So the most recent question that came in is, after a CCNA, should I go for an MCSA? Like I mentioned, after you get your CCNA, the concepts of networking, of routing and switching, specifically with Cisco's way of doing routing and switching, is going to be very fresh in your mind, right? You will have studied for several months to get your CCNA. I would say before you go off and do something Microsoft related or Linux related or VMware related, while the Cisco stuff is still fresh in your mind, get your Cisco CCNP first. And then you can branch off to something else if you want to after that. But you're going to kick yourself if you get your CCNA and then you spend 6 to 9 months studying for a VMware certification or an MCSA. You get that, and they say, okay, let me go back to do my CCNP now. And you realize, oh my gosh, I've just forgotten a ton of stuff that in my CCNA would have helped me with my CCNP studying. So that would be my recommendation. Let's see here. Let me scroll up a little bit and just see if there's any unanswered questions here. I see there's also a few questions going around about packet tracer and simulators and emulators and things like that. Let me just talk briefly about that. So if you are pursuing a Cisco CCNA, which is the first level certification that Cisco offers, packet tracer is great. I love packet tracer. Now it does have its some limitations, but as far as getting some hands-on experience with what you need to know for a CCNA level, packet tracer is fine. And packet tracer is free. Just go to Google and Google download packet tracer. You'll have to register for Cisco's Networking Academy, but that doesn't mean you have to do anything. You don't have to go to any classes. You don't have to go to any school or building. Just register for Cisco's Networking Academy, and then you'll get a free download of packet tracer, and it's fantastic for any CCNA stuff. Now, beyond that, for like CCNP or anything beyond routing and switching, at that point it falls kind of short. You see, packet tracer does not use real Cisco iOS software. You might be asking, iOS, what's that? That's the first time I've heard of that. The specialized networking software that runs on Cisco routers and switches is called their internetworking operating system. So whereas laptops have Windows operating system or Apple's iOS, well, Cisco has their own internetworking operating system. So that's the operating system that runs on their routers and switches, and that's what you need to learn how to operate in order to pass your Cisco certifications. Well, packet tracer is not real iOS. It's a software program that's designed to look like and feel like iOS, but it's not real iOS. And so there are certain commands in there that are not available, that you just won't find in packet tracer. So if you're getting the higher level certifications, at that point packet tracer doesn't really work so well, and you'll want to go into like GNS3 or renting time on racks or something along that nature. Let's see here. What else? What other questions do we have? So another person asked a very good question, very practical question. How do we manage learning all this stuff in addition to working a regular day job? Great question. It's not easy. So you're going to have to become disciplined and dedicated to setting aside some time each and every day to learn this stuff. You'll have to basically say to yourself, okay, for the next 6 months, no more TV. When you go home at night, you're not going to watch television. You know, after you eat dinner, you're going to spend 2 or 3 hours a night, every night, studying this technology, reading books, making flashcards for yourself and quizzing yourself on the flashcards, logging into simulators or emulators or logging into real equipment and doing labs, making labs up yourself and then practicing them. But certainly if you have a regular day job, it's not easy. And that's the reason why these certifications are hard, is because most people have to juggle learning all this new stuff in addition to what they're doing during the day. So you just have to be dedicated and set aside time on the weeknights and weekends to do that. Just looking to see if there's any other unanswered questions here. Looks like a lot of people also weighed in on their ideas of packet tracers, so that's good. The one of the downsides you will have if you are working, how do I phrase this? If you don't have access to real equipment right in front of you, and I'm not saying you have to have a huge lab of stuff right in front of you, but you ideally would want to have at least a couple of pieces of gear physically right in front of you, because there's some stuff that you can do with real gear that you can't do with emulators, you can't do with simulators, and quite frankly, you don't want to do on remote equipment. For example, one thing any network administrator would need to know how to do is how to upgrade the software or downgrade the software in their router or switch. Well, you can't do that on a simulator or an emulator. Now, technically, you probably could do that if you're logged into somebody else's remote rack, if you're renting time on equipment, but here's the downside. When you're upgrading or downgrading software, as I'm sure you know, if you've ever tried to do it on your laptop or your PC, all kinds of things can go wrong. Well, typically, if you're upgrading or downgrading software on a router or switch, if something goes wrong, you have to be there physically to fix it. You have to be able to see what the error messages are. You have to be able to get into some sort of disaster recovery mode to try to fix it. That's something you can't do if you're renting time on a remote rack. If you're trying to upgrade or downgrade software on a remote rack and something goes wrong, typically you're just kicked out and you're stuck. You can't do any further troubleshooting beyond that point. So having a real router or real switch physically in front of you can help you with that. Cabling issues, right? You know, what are you going to experience if you don't plug in a cable all the way? If some of the pins aren't touching or some of the pins are bent, what's the result of that? Well, once again, you need to have physical equipment live in front of you to actually be able to experience that, as well as other things as well. You know, what happens if you accidentally try taking a network module out of a router, and that particular model of router does not support what they call hot swap. Hot swap is a router that says, okay, while I'm running, you can put a new network module in me. You can take a network module out while I'm running and it won't bother me. It won't affect me in any negative way. What if you're in a router or switch that doesn't support that? What will you actually see if you take a router or a module, or if you take a switch, if you take a network module or a card and you pull it out while the thing's running? It's good to be able to experience that yourself. Let me look through some of the other questions here. Somebody's asking, do you think 4 months is enough for someone to get ready to pass the CCNA exams? So in order to pass the CCNA, you have two choices. So the CCNA is, you can either take two separate exams. There's the ICND 1 followed by the ICND 2, or you can take what's called the composite exam. The composite exam is really geared towards people who have already been working to some extent in the networking industry. You already have some real world experience. For example, let me throw out some terms at you. If you know sort of what these terms are, Ethernet, IP address, LAN and WAN, subnetting, routing protocol, spanning tree. So those terms I just threw out at you. If you were like, what? I have no idea what those are, then you don't want to take the composite exam. But if you knew what most of those things were, or at least it gave you some ideas in your head as far as what those things are, you could probably take the composite exam. But most people go for the two separate exams rather than taking the composite exam. And I would say for each separate exam, I would say, 3 to 4 months is probably the minimum you'd want to study before passing your ICND 1, and then another 3 to 4 months before passing your ICND 2. And when I say 3 to 4 months, I'm really talking about someone who's dedicated to putting in a minimum of 2 hours a day on the weekdays and 3 to 4 hours a day on the weekends, consistently every single day for 3 to 4 months. Let's see here. Somebody is asking also, should they know Python programming as well? Python's very popular. It's gaining more and more popularity. Somebody had asked me earlier about scripting, shell scripting, and Python programming falls right into that. Typically, when it comes to working in networks these days, if you're applying for a networking position and you can also say that you know Python programming, that's good from the perspective of if you're going to be working in the type of job where, like I described, where you have to frequently log into multiple devices and issue the same types of commands over and over again, and you want to automate that process. You want to automate, when you receive the same type of data, looking for certain trends, you want to automate that. Python programming is very useful for that, so it would help you in that regard. I don't think you specifically need to know Python for the CCIE data center, but it would certainly help you getting a job after that point. All right, so we've been going for about an hour and 15 minutes. I don't know about you guys, but I need a short break. So let's take like a 10-minute break, and then I will see you guys in 10 minutes.
Our sessions are very interactive, always available to answer any questions during the session or offline.
They give you, he gives you the right mentality you need to approach any problem or troubleshoot or, answer a question on a test.
It's helped me a lot, even stuff that's not even for the CCIE, I had the all access pass. just the knowledge that you get from them. You know, not only like, you know, this is how you configure it, but they actually show you in the video, this is how it works. And that's what you need. You can't just read a document and be like, well, this is the configuration. So hopefully it works, because sometimes it doesn't work.
I wish that I'd start off with material just like this, because I would have understood right off the bat what the theory is and what it's actually doing in the command line.
It's definitely more advanced. I think it's explained in a better way, better analogies. I think it's tougher, which is good. You know, I took one that was earlier and it was easier, you know what I mean? So it gave me this false confidence. And so now getting into this stuff and you see like, wow, this is a little bit more advanced. So, you know, I want to do some more of this stuff, and now I'm starting to feel way more comfortable.
A few of the weak spots that I had, I'm able to get over those things and understand those things better.
It's easy to study for a test and just study exactly what you need to know, but in this class we've gone kind of above and beyond, and he showed us things that can actually apply in real world, and some things that may not be applicable to the exam, but are good things to know, especially when troubleshooting. And
I definitely recommend it. I've been recommending it. Just using the materials, now going to the camp, I'd recommend it all day long. It's a completely different learning experience.
Welcome back, everyone. So let's go ahead and pick up where we left off. So this next section here, I'm primarily going to whiteboard for you when I talk about the common technologies and terminology that work in a network. Specifically, you're going to hear these terms. I've mentioned them a little bit in the Q&A, go into a little bit more deeply now, which is routing and switching, data center, collaboration, and security. What is that stuff? When it comes to like technologies and network, where does all that come into play? So in order to do that, let's go ahead and bring our whiteboard into play. So as I mentioned earlier, we've got this concept of we have a bunch of devices. I'm just going to draw them as laptops here, but they could very easily be IP phones, what have you. And we know that each one has its own separate cable, and those cables all terminate at a central device we call a switch. And we probably have different departments. So there's switch 1, switch 2, and let's just say down here is switch 3. Okay, so the concept behind switching when it comes to networking technology are understanding things like, how do I physically connect things into this switch? How do I issue commands on the switch so that its interfaces respond correctly to these laptops or PCs that's connected to? That the interfaces know they're in the correct group, that the interfaces know that they're supposed to operate at the correct speed, have the correct security restrictions. When I connect my switches together, is it best to use one cable or two cables to connect them all together? Protocols and features that run within the switches, like something called spanning tree, which is designed to prevent endless looping of data from one switch to the other, just going in a circle. How's that protocol work? So switching is all about how do you do that? How do you manage these switches? How do you configure the features on them so you get the most efficient networking you can in this switch environment? Now, routing has to do with, let's say that this is all in one building, and then I have a router right here, which is then connected to maybe some other sections of my building. All right, so we'll just put a little cloud right here, put a little cloud right here. Maybe this is building 2. Maybe this is building 3. The router also has connectivity to another router across the city. So we'll just say this is router 2. And here's another router that's in another part of the city, maybe another part of the county. Or maybe if I have a really large campus, another part of my campus. And so these routers are all connected to lots of other different routers. So let's put little R's right here. So routing technology involves same type of thing as switching. How do I physically connect things to the routers? What type of cabling should I use? What type of technology should I configure on these cables? What type of security features should I configure on the routers so that data can only go one place but not another place? Another big component of routing technology is, let's say I have this laptop right here in red, and it needs to send some information to this server right here, which is also in red. Well, so that information is going to hit this router, and at this point, this router right here has several different paths it could take, right? In this case, it's only 2. It could either go directly to the right or it could go down. But in an environment where there are multiple paths going through multiple routers to reach a given destination, another aspect of routing technology is, how does the router learn of the paths? How does it learn which path is the best? How do I configure the router to manipulate one path over the other as being better or worse than another path. So routing and switching is all about how do I get my data through the network in the most optimized way, making sure that nothing gets dropped, everything gets there as quickly as possible. And if something changes in my network, for example, if this link right here were to go down, were to disappear, how do I understand the technologies well enough so that I will know, number one, how will I be alerted when that link goes down? Have I configured my network to adjust very, very quickly if something like that happens? So that's what routing and switching is about. So when we talk about routing and switching technology, it's all about configuring routers and switches and those types of things. Now, the other technology that was on this list was data center. So let's take a look at that for a second. What are data center technologies? Now, this is specifically referring to networking here now. So we have, this is this big cloud here. Let's just say that represents my company. And all the dozens or hundreds of departments I have, all the different floors, all the different buildings. And then that leads into a room where I have all my servers. So this is my data center. Well, data center networking is all about answering questions like, okay, I need to get some specialized switches that these servers connect to. Because these servers are carrying my mission critical data, I need, number one, I need to make sure these switches are very, very reliable. They're very expensive because they're highly reliable. They basically never crash, they never go down. In addition to that, these switches have special connectors that go to these servers that can transmit and receive data much, much faster, much, much more reliably than the typical connector you'd have going to a laptop or PC. So data center networking is understanding what those connectors look like, how they work, how they connect up to the switch. Another aspect of data center networking is a lot of times in a data center, the servers themselves, the information they're storing isn't necessarily on their own hard drive. The information they're storing is stored on a remote hard drive called a RAID array. I believe that stands for Rapid Array of Inexpensive Disks, or maybe a redundant array of inexpensive disks. But it's basically a whole bunch of hard disks in one physical box. And then these servers will have special connections via special switches to this RAID array. So the question now in data center networking is, do I understand what type of switch can connect to this RAID array? Do I understand what type of connectors are used for that? So there's all sorts of features that are involved in a data center because you're talking about massive quantities of data, so you have much faster links, a lot more redundancy, a lot more security in place that's specialized just for data center networking that you wouldn't normally need to know about when you're talking about connecting to your end hosts, like your laptops or your PCs. So data center networking is specializing in that aspect of it. Collaboration. So if you think about, in addition to just regular data, what else could I use my network for? For example, a long time ago, people realized, hey, we could connect our phones to this network and use the exact same wires that are carrying our web pages and carrying our emails to also carry our telephone conversations. We could use this network to carry video, like from our video surveillance cameras around our building or around our campus. Our network could connect to that. We could use the same network to do like virtual meetings, like using WebEx or telepresence or something like that. So collaboration is all those types of video and audio components that are added to the network. So the technology involved in, how do you get that to happen? How do you connect up video cameras to a network? How do you connect up IP phones to a network? How do they talk to each other across the network? How do you keep their traffic separate and distinguishable from the regular data traffic? That's all collaboration technologies. And then of course there's security. Security is dealing with things like, how do I protect my network from threats from the outside? How do I protect my network so that somebody from the outside isn't trying to intentionally crash or disable some of my servers or some of my networking devices? How do I protect that? How do I protect my network from accidental mistakes on the inside? What if an employee brings a router or switch into their cube that they bought off of some eBay or Best Buy website or something, and now they're connecting a rogue, unauthorized networking device to my corporate network? I don't want that. How do I protect against that type of thing? So anything that you can think of as far as protecting the network, protecting the users on the network, that goes into the realm of security technologies. So let's move on into the next section here. And I want to talk a little bit about networking job roles and descriptions. So if you're going to go work on some computer network somewhere, either in a college or at a service provider's office or in an enterprise network like a company or business, well, chances are you're going to have lots of different tasks that you're going to do. And computer networking job roles will typically require you to perform one or more of these duties. Let's go through each one of them. So, network analysis. So that's typically reserved for more experienced networking people. Someone who's well-versed or well-experienced in networking analysis is somebody who can go into an existing network, take a look at it. They can thoroughly understand, what was this network designed for? What were the objectives when this network was built? What was it supposed to do? What type of data is it carrying right now? How utilized is it right now? What are the needs of this network going to be a month from now, 6 months from now, 5 years from now? Let me look at this network from the eyes of, is it doing what it was supposed to do? Is it optimized? Is it working as best as it possibly can? And is it well situated for future growth? That's someone who's really good at network analysis. And like I said, that's more of a future job role. That also ties very well into network design. So some of the differences between network analysis and network design is, I think of network analysis as being someone who is a regular, W-2 paid employee of a company. They're on staff, they have a salary, they have benefits, and part of their job is just to look at the network like once every 6 months and answer those types of questions. Is it doing what it's supposed to do? Are we well positioned for, we've been involved in lots of meetings. We know we're going to be hiring some new companies, acquiring some new companies, laying off some people. Is the network ready for all of that? Whereas network design is typically where someone is brought in from the outside, like a contractor. And for a duration of time, like 3 to 6 months, their job is to either design a brand new network, like maybe a new coliseum or a new stadium is going into a city, and they have to design the network that will be there, or a new arena is going in, or a new office building is being built. So they will design a network from the ground up. And it's a short duration, it's a contract position. They get paid a lot of money, and they assess all the needs. They have a lot of meetings. They talk to a lot of the stakeholders, and they figure out what the network is going to need to do, and then they design it. And when they're done, they come up with a big, thick project plan of, this is what I think you guys should do. Here you go. And then they walk away. They don't actually implement it. Network implementation is actually the job of buying the stuff, buying the routers, buying the switches, making sure you're getting the correct hardware and cabling everything up, turning it on, making sure that you've got the correct power source. You have enough power to power everything. You have enough heating and cooling to make sure that everything isn't getting overheated. Configuring the devices, configuring them for Ethernet and all these different protocols, making sure they understand routing and switching and putting all those security features on it. So actually getting your hands dirty by logging into the devices and getting them to do what they were designed to do. That's network implementation. Network troubleshooting, I'm sure you can figure that one out, right? Something breaks, your job is to fix it. Figure out what the root cause was of why it broke. Not only fix it, but make sure that root cause doesn't happen again in the future. And then network monitoring. This is someone who typically is like looking for the red and the green lights, right? Their job is to monitor the network and make sure that nothing goes down. If something does go down, they report it to the network troubleshooting guys. Monitor device to see, hey, this device is not operating quite well. You know, its brain, its CPU is almost maxed out. Every time I log into it and look at it, it's almost at 100% maximum capacity. So as a monitoring job, it's like, okay, I might want to talk to the network analysis or network design people to see if maybe we should swap that out for something stronger, bigger, more powerful. So that's network monitoring. So depending on what type of job you get, and more specifically, what type of company you work for, you may be asked to do one or more of these roles. So where these fall into, let's take a look at these jobs here of network architect, engineer, administrator, and technical support or help desk. So let's start with network engineers and network architects. So a lot of times these terms will blend, network engineer, network architect. When they are distinct, when they're separate, here are some characteristics. A network engineer, let's start with a network architect. So a network architect, like it says, is generally hired to work on larger networks, and they're generally hired as consultants. So a network architect will come in temporarily for like a 6-month or a 9-month position with a defined task. Here's your project. Here's your objective. Design this network. You know, give us some project plan that once you leave, we can implement. Now, the network engineer, a lot of times, is a paid employee. The network engineer will typically take what the network architect came up with. The network engineer will take that project plan and implement it. The network engineer will purchase the routers and switches. The network engineer will decide exactly what configuration commands should be done to implement the security that the architect recommended, implement the redundancy that the architect recommended. The network engineer will also do prototype testing. So this is not really something the network architect does, but the engineer will. So the network architect might say, okay, based on my design here, you should have 500 routers all doing this one particular protocol in this particular way. Well, before you spend hundreds of man hours and millions of dollars buying all that stuff, the network engineer might purchase 10 or 11 of those routers, build it up into a lab environment, and test it. You know, will it work? Will this protocol the architect recommended actually work in this environment? Can I get it to do what the architect said it should do? So that's something a network engineer will do. So an architect really is equated to design, and engineer is really equivalent to implementation. So for example, if we take a look at this topology right here, and I'm going to expand this a little bit. We've already seen this. And if we're trying to answer the question, what value does a network architect bring to this topology? Well, here's the types of questions that a network architect would ask you when looking at this topology. They would say, how many users do you have now? Where are they located? How do you see yourself scaling in the future? What types of information is the network carrying now, and what types of information do you think it will carry in the future? What kind of service level agreements do you need? How do you need to separate or group your traffic for security or quality reasons? Tell me about your building. What materials are your floors and ceilings made out of for like Wi-Fi planning? And then they'll draw up a topology and a project plan based on questions like this and give you the results of that. Now, if we take a look at that same exact topology, but from the perspective of the network engineer, the network engineer will now perform proof of concept testing with like simulated environments or smaller scale mock-ups. The network engineer will probably decide on specific models of equipment and specific types of software. If IP subnets have to be purchased, from a registry, the network engineer will do that. The network engineer will make decisions regarding the design and implementation of smaller scale change requests. For example, there's a need to upgrade a link or purchase a different switchblade or implement some additional redundancy. The network engineer will figure out how to make that happen. Now, if you're watching this show, which you are, chances are you're not going to be jumping into the role of a network engineer or network architect anytime soon. You will probably, after you get your initial Cisco certifications, the first role you'll be looking for is what we call the network administrator. Sort of like the entry-level position a lot of times. So what does the network administrator do? Because this is more likely what your first job role will be. First of all, you should be aware that unless you work for a company that has a really, really large network, chances are network administrators are going to be expected to work on the servers as well as the network itself. And you can see right here, some of the things on servers that you'll be expected to know is there space available on the servers for users? Or do I have to add some more memory to my servers? Do I need to purchase some additional servers? Capacity planning, backup plans, creation of credentials and files and directories. So that's all the stuff. Now, in addition to that, hopefully you'll get some networking hands-on, and so you'll be able to install and configure new equipment, cable the equipment, and implement change requests and implement upgrades. So the network administrator, look what's missing from this list. Design. The network administrator is not expected to be able to make recommendations. The network administrator is not going to say, here's a particular model of router switch I think you should use. Or here's a particular protocol I think we should implement. Or I think we need security over here in this part of the network, and here's why. The network administrator doesn't do any of that stuff. That's all stuff for the network engineer. Now, another type of entry-level position you might get is the technical support engineer. This is the person that provides phone support and remote troubleshooting support. So technical support engineer is not going to get hands-on experience of hands-on installation of equipment, but you will get great foundational knowledge of software and network operating systems. So a technical support engineer is a great position to gain that initial knowledge across a broad spectrum of technologies without actually being responsible for racking and stacking equipment. So when employers are looking to fill these roles, when employers are looking to fill technical support engineers or network admins, what type of personality characteristics are they looking for? Or are they hoping to get? Well, number one, got to be highly organized. You're going to have a lot of different tasks going on all at the same time. You need to be able to prioritize and organize things so things don't slip through the cracks. You should be able to enjoy learning new things. Networking technology is changing all the time. And so you should be able to keep up to speed on the latest developments and what's happening in the world of networking. Willing to work off hours. You know, a lot of times you might have to come in the early morning or late evening hours to perform your software upgrades or to swap out faulty hardware with replacement hardware. So you got to be willing to do that every once in a while. Hopefully not too often. You got to be a critical thinker, right? You can't be someone who gets all flustered when there's troubleshooting. You're going to have people coming at you who are flustered. People who are coming at you because the network's down and it means they can't do their job. They're losing money. They're stressed out. You have to be able to not be impacted by their emotions, but be able to sort through what they're saying to identify the actual problem that they're experiencing and then take that back with your knowledge and figure out the best solution for that problem. Clearly, you have to work well with others. If you're the type of person who would rather work in a storeroom somewhere where there's nobody else around, probably don't want to do this job. And you have to be able to sit in front of a computer for extended periods of time. Network engineer, network admin, network troubleshooter, not someone who's going to do a lot of walking around. Every once in a while you will, but it's mostly, you know, sitting in your cube, in your office, doing stuff based in front of your computer. Now, if that describes you, let's talk about network administrator. I just gathered here from some different websites And you can feel free right now, I'll go ahead and expand this, to take a snapshot of that if you want, and then go directly to those websites. You can see that the pay scale for a network administrator is fairly wide. Now, all of these is based on the United States. So if you're watching this from a different country, you'll have to go to whatever websites are appropriate for your particular geography. But here in the US, you can reasonably expect to get paid like a minimum of about $40,000 a year as a network administrator, and then it can go all the way on up to $105,000 if you're working for a really large company. You have quite a bit of experience. But you can see it seems to be around the $60,000 to maybe $70,000 a year range. All right, so it's been a while since I've taken any Q&A. Let's go ahead and see if there's any unanswered questions here for me. So I'm going to ask, which college degree is needed to work in networking? Technically, you don't need a college degree. I mean, honestly, if you, and I'll talk a little bit about this in my next section, is, where do I go from here? That's the next section we're going to talk about. But if you have certifications, for example, at a minimum, I would say you should have at least a Cisco CCNP certification. Tons of people out there with Cisco CCNAs who are trying to get jobs as network admins, but most job postings that you'll see say that they are requiring at least a CCNP or higher, or CCNP preferred. So you'll definitely be ahead of the game if you get at least a CCNA and a CCNP. And I would also recommend that you get some experience with servers. Maybe play around a little bit with Microsoft servers and Active Directory and all that good stuff, Microsoft domains. There are some colleges that offer degrees in networking. But honestly, I think if an employer is looking at two different resumes, if one resume has a 4-year bachelor's degree in computer engineering and networking, the other has a CCIE in routing and switching, they're going to pick the CCIE, most likely. Not always, but most likely. Someone's asking, is this a rebroadcast? Kind of. So we do this particular session, this introduction to networking thing, about once every 3 or 4 months. So I did do it previously. So everything I'm talking about here, I did previously talk about as well. So this is just for a new set of people. What other questions do you have? How to relate job roles with Cisco certifications? Good question, Salim. So your CCNA, CCNP, and CCIE are really all geared towards people who are going into the network implementation and troubleshooting job roles. So network admin, network engineer. So once you get your CCIE, you're well positioned to become a network engineer someplace, someday. But if you want to go more into the design and analysis aspect of networking, well, first of all, that's going to require experience. You can't just jump right into that. You'll have to spend some time as a network engineer before you go into a network architect. But those are the design certifications. So for example, Cisco has the CCDA, the Cisco Certified Design Associate, CCDP, Design Professional, CCDE, Design Expert. So if you want to go into design, you want to go up that track, all those certifications that have a D in it. And at the very top of the food chain, there's something called the Cisco Certified Architect. I'll talk about that coming up here in a little bit, but good luck with that one. Hardly anybody in the world has that, and we can talk about that later. Someone's asking, what do you think about CCIE versus SDN? SDN stands for Software Defined Networking. In order to really understand SDN and to actually utilize SDN, and right now software defined networking is still quite in its infancy as far as where it's going to go in the future, you still have to have a good foundational knowledge of networking. You might not need to go all the way up to a CCIE, but if my job role was to work with software-defined networking, I would at least need to have a Cisco CCNP certification. Then I'd also want to know something about programming. Software-defined networking these days requires scripting knowledge and programming knowledge, which I don't have, but that would be sort of required for that type of job as well. So yeah, so Daryl asked, so CCNA is not network engineer? That is correct. Once you get your CCNA, you could potentially start interviewing for network administrator positions. But like I said, you're also going to have people with CCNPs applying for that same network administrator position as well. Network engineer, really got to have a CCIE and some years of experience to do that job. Somebody's asking if I do a course for subnetting. I don't have any right now, any YouTube live courses for that, although we could probably put one of those on the schedule if you think that would be interesting to you. I do have a lot of videos that I've recorded on subnetting, just nothing on YouTube live, but that might be something I'll do in the future. That's actually a very good idea. All right, so let's look at the next category here. And this should go fairly quickly because I've already covered much of this stuff. Computer networking technical specialties. There might not really be anything I can add to this. Let's just take a look. Okay, so like I mentioned, if you could be privileged and actually go to work for a company that has a really large network, and then you have the privilege of working not only just on the network, but within a certain specialty of that network. And we've already talked a lot about that stuff. For example, if you are a routing and switching engineer, then your specialty is how to get data from point A to point B, how to get the network to learn of all the destinations out there, how to get the network optimized so it chooses the best path, if there's congestion in the network, how to account for that, and make sure that the least important things get dropped, not the most important stuff. How to enable the network to differentiate between different types of data and treat each according to prescribed requirements. In other words, if this network is carrying both voice and data, a routing and switching engineer should be able to program the network to be able to recognize that. To recognize that, oh, this information right here is voice, and this needs to be treated much differently with a lot higher priority than my data. You need to know how to configure and program the network to do that. Identifying various ways to partition networks for basic security requirements and scalability. That's also something a routing and switching engineer should be well versed in. Security engineer, we talked about that. Your job is to identify and protect the network against security threats. You are familiar with security-specific networking devices such as firewalls and intrusion detection and intrusion prevention devices. You are familiar with security-specific networking software such as virtual private networking and encryption and how to implement all of that. So that's your job if that's your specialty. Device hardening, how to make sure that only authorized people are allowed to get into the command line of your routers and switches. As a network security specialist, you know the various ways to accomplish that. What if your specialty in your network is in the area of data center? Well, then you're going to be familiar with how to unify storage, computing, and networking resources to simplify a data center. In other words, sure, you could have a room, a data center, where you've got this device here that's just doing storage, just storing all your data. You have another device here that's got a lot of brain power, a lot of CPU. That's the thing that's really crunching your numbers and doing all of your high intensive computing. You've got another device here which is just a network switch. Well, is there a way to simplify all that stuff? Is there a way that you could possibly buy a device that has computing and storage power inside of a switch? Yes, there is. So you will be familiar with how to do that. What are the devices out there that are optimized for network? You'll be familiar with, okay, in this room that's got all these servers and this storage and stuff, how do I optimize the network so that if this particular section of my data center is requiring a lot of the network right now, a lot of my networking resources, my bandwidth, my switches can shift over here to make use of these servers. How do I optimize the paths of the network? Maybe I can have certain types of servers and certain data go along predefined paths in my data center that's not used by other stuff. And collaboration, we talked about that. How do you implement video? How do you implement voice into your network? How do you make sure that that stuff doesn't negatively impact and negatively interfere with the data on the network? And vice versa. How do you make sure the data doesn't negatively impact the voice and video on the network? And of course, there's Wi-Fi specialists. How do you implement Wi-Fi into the network? How many access points do I need in a given space? Where's the best place to place those access points? How many users can be on one access point at a given time before I need to think about, okay, I need additional access points? How do I separate my different groups of Wi-Fi users? How do I implement my Wi-Fi security so that people who are in my lobby have a certain accessibility to Wi-Fi, whereas my employees have a much broader accessibility to Wi-Fi? There's also service provider specialties. For example, you might see that Cisco has service provider certifications. There's a CCNA in service provider, CCNP in service provider. What is that? Well, one thing that makes service provider networks different than enterprise networks. Now, you might not be familiar with that term, enterprise network. What that means is that's a network that's within a company. That company uses that network for their own internal processing, their own internal emails, their own internal web browsing. That's an enterprise network. Well, how does that differ from a service provider's network? A service provider's network, number one, has a lot more traffic going on it, right? A service provider's network is used not only internally for their own employees, but it's also passing traffic back and forth between tens or hundreds of thousands or millions of customers. So a service provider's network has to have a lot more bandwidth, handle a lot more traffic than an enterprise network. So as someone who is a service provider specialty will know how to implement that. They'll know how to optimize that. They'll know, a service provider's network will need a lot more security because this is a network that's being shared among hundreds of thousands of people. So we need to make sure that this network is very, very secure, no risk of someone damaging it, bringing it down, doing a denial of service attack. So someone who's well-versed in service provider technologies will know how to protect the network against those types of things. So that is where someone with service provider specialty would work. So the last topic I want to talk about today is, where do I go from here? So we've now talked about some of this stuff and you're thinking, hey, this is something I might want to do. I might want to investigate a little bit more into computer networking. What do I do next? So what are the next steps? So number one, this is what I'd recommend that you do. Find someone who does the job. If you're at a school, your school has a network, find out who the network admin is for your school. If you're at a company, find out who the network admin is at the company and talk to that person. Get to know them. Ask them questions like, what do you do? Tell me a little bit about what your job is day to day. I think I might want to someday do what you do. Can you tell me a little bit about, what's your day look like? What types of fires do you have to put out? What do you like about your job? What do you not like about your job? What experience did you have prior to getting hired? What skills do you consider to be important for your job? If I want to do what you do someday, what type of skills should I have? And ask them for a roadmap. Say, hey, I admire you. I like what you do. I want to do it someday. This is what I currently know. What would you suggest I do to get from point A to point B? People love giving advice like that. So talk to somebody who's already doing the job. Get to, ask them if you could shadow them. Say, hey, the next time you need to go into the wiring closet or you need to do something, can I just look over your shoulder, see what commands you're typing and, ask you questions about what you're doing? See if they're amenable or open to that idea. Another thing you can do, YouTube, right? There's actually a lot of network engineers on YouTube that talk about their jobs, that answer questions like this. If you search for Eli, the computer guy, and he's not the only one, but one of his specialties is interviewing people and asking them questions like those bullet points above. And so you can see lots of different network engineers and their answers to his questions and his interviews, and they'll give you a really good idea as far as what you can do. Another thing I'd recommend, buy yourself a small lab, real small lab, 2 routers and a switch. That's really all you need to get started. And I'm recommending here that you get some 3725 routers. And the reason I'm recommending that particular model is because if you go into using GNS3 later, you will need a real Cisco software image that works with GNS3. And the 3725s, their Cisco iOS software does work in GNS3. Get yourself a multi-layer switch like a 3560. You can see they're pretty cheap. Those can also double as routers as well, so you can practice both switching and routing on those devices. With that physical equipment, get familiar with these things here. How do you connect your laptop to the console port of a router? What is a console port? Watch some videos on that. Get familiar with the LEDs, the lights on the front and back panels of the routers and switches. What do they mean? What happens to those LEDs when you plug and unplug something? Experience with cabling. Like I mentioned earlier, experience with upgrading and downgrading software on your routers and switches. Experience with password recovery. If I lock myself out of a device and I don't know the password, what do I do about that? Google it and try it out. Get familiar with that. Sniffer traces. You can go to wireshark.org. Put that right here. You could do this right now. Wireshark.org. And download their free software. And that allows you to see all the Ethernet frames that your laptop is sending and receiving, everything. It gives you visibility into stuff that normally you don't even know what's going on in the background. That's what we call a packet sniffer. I definitely recommend you download that and play around with it. It's free. And I believe this playlist right here, let me just exit out of here for just a minute. If I bring that up, all right, so if I go to this, hopefully it'll come up. It's been a while since I've looked for it. Yeah, so here at INE, we have rack rentals that are available if you want to start playing with larger topologies. And this series of videos here talks all about how to rent our racks, what's involved in renting a rack. You can see it's all on YouTube. It's all free for you. I'll go ahead and bring the slide back so you can do a screenshot of that URL right there. I'd recommend spending some time on our rack rentals and playing around with them. And then lastly, start pursuing some certifications. I would start with the entry-level certifications. I would start with the Cisco ICND 1 which is getting you your CCENT. You know, purchase the ICND1 book, start reading it, make flashcards for yourself. And I also have a whole video series on how to prepare for a Cisco CCNA. What are some of the pitfalls? What are some of the strategies? So I talk about that. But, you know, give yourself an objective. Give yourself a goal of getting a CCNA, and then work up from there. CCNP, maybe get an expert level certification at some point. The CCAR, which is the Cisco Certified Architect, that is an amazing certification. First of all, it's very, very expensive. It's like $15,000 to do that. There's less than 12 CCARs in the entire world. That tells you how rare it is. But hey, you know, if you are super ambitious, you could go for that and then guarantee yourself the big bucks if you actually end up getting the CCAR. And like I mentioned, any Cisco certification that has a D in it, like CCDA, CCDP, those are all geared towards the design spectrum. You definitely want to, I would definitely recommend starting out with a CCNA in routing and switching before you do anything else. So with that, that is all I have for today's show. So let me go back and let's do a Q&A one last time before we wrap it up here and see if there are any unanswered questions. Nikhil is asking, can I explain the role of a Cisco voice engineer? That's the same thing as collaboration. A Cisco voice engineer is someone who is well versed in what's an IP phone? How do I connect an IP phone to a network? How do I, when I connect the IP phone to the network, you have to connect other things to the network like servers and things, so when you pick up the IP phone, it gets its own telephone number. It knows how to dial another telephone number. The network is optimized, so when IP traffic that's carrying voice gets into it, the network knows, oh, I need to optimize this voice. I need to prioritize this voice traffic over other types of traffic. So the voice engineer will be very familiar with how to get all that stuff working. Which Cisco certification path is the best? That's really up to your own personal preference. I and many other people would recommend you start with routing and switching. CCNA, CCNP, and routing and switching. At that point, you could branch off if something else interests you. Can I give some bits of aspects of networking related to Amazon Web Services, AWS? That's really sort of related to data center and cloud computing. So if you're interested in AWS, first of all, that's Amazon stuff. That's not Cisco. But AWS is all related to cloud computing and data center. So you'd probably want to specialize in that kind of stuff for that. Slobodan, I see your question there about comparing and contrasting the CCNA routing and switching to the service provider. I have not taken any of the service provider exams, so I really can't contrast them. I've pretty much stayed purely in the routing and switching track, so I can't really tell you too much about what to expect on the service provider stuff. And yes, I do have a full video course on the ICND1. I can give you an example. If you go to streaming.ine.com, this right here will show you all the courses that we have. And as far as the ICND1 is concerned, if you click on Cisco, and then if you click on CCENT, you'll see right here on the left, this course is our ICND1 course. And if you click on that, you'll see the various videos. Now, you won't be able to watch these videos unless you've purchased this course or you've purchased an All Access Pass. But these are all the videos I've created as part of the ICND1 or the CCENT course. ICND2 is just part of the CCNA. You just get more exposure into ICND1 topics, and you get exposure to some new features and protocols that are only part of ICND2. For example, most of your routing protocols like EIGRP and OSPF, you get exposed to that in the ICND2 curriculum. Most of the more advanced switching features like spanning tree, that's in the ICND2 curriculum. As far as the security track, I would definitely, once again, recommend you start with the CCNA in routing and switching, and even a CCNP in routing and switching. There's a lot of security features even in that track. So in the routing and switching track, you're still going to find a lot of security features. And then from there, you can branch off into like the CCNA in security and the CCNP in security. Somebody's asking, what is the concept of a VPN? Good question. So VPN stands for Virtual Private Network. So imagine this for a moment. Imagine if you and I were on our laptops and we are connecting to a shared network. Let's say that we're in the same building, but we're on different floors. I'm on floor number 1, you're on floor number 12. And in order to talk to each other, we have to connect to a network that a lot of other people use as well. A VPN is, how could we send information back and forth to each other in such a way that it's on the shared network, but if somebody else was able to see our data, they wouldn't be able to tell what it is. They wouldn't be able to tell what we were sending back and forth to each other. They wouldn't be able to understand it. They wouldn't be able to inject stuff into our conversation to confuse us. How would we do that? That's what a virtual private network is in other words, having some sort of network connection between two devices that's private, that is, and yet that communication's using a shared network. And there's all sorts of ways to accomplish that. Nikhil asks, currently doing CCNA routing and switching, is it necessary to go to the next level to get better salary jobs? Absolutely. Absolutely. I would definitely recommend that you at least go to an NP level. And yes, I am the instructor here at I&E for the, well, let me put it this way. If you get an I&E All Access Pass, that's a subscription you get for like 6 months or a year or 2 years, and then you get access to all of our videos. So if you look under the CCNP routing and switching, I'll do that right here. So under Cisco and CCNP routing and switching, you'll see there's a lot of videos here by people other than myself. For example, we have Travis Bonfigli, we have Rob Riker, even Brian McGann has put in some, and you'll see many of them are from me. So I'm not clearly the only one that has created routing and switching CCNP videos. Now, if you were to actually attend a live CCNP routing and switching boot camp, which is where you come here to Raleigh-Durham and you sit in a classroom environment, then you would get me. So I am the only instructor who teaches the CCNA and the CCNP routing and switching live classes that are live boot camp, classroom environments. All right, and we've already talked, Alhaid, we've already talked a little bit about scripting languages like Python, etc. It's definitely useful to know, especially if you're working on a large network where you need to automate some very common redundant tasks. All right, so with that, I think I'm going to go ahead and close things up at this point. We do have, by the way, coming up, and you can also look at this here, if you log into your members dashboard. Remember how at the very beginning of today I said if you get a free I&E account, you can then log into the members dashboard. I'll log into it here. And here you see our calendar of events. The ones here in dark blue are our live classes, where you actually have to fly to San Jose or RTP and participate. But we do have something coming up. Let's see here. When is the first one? I think the first one is actually in January. Where is it? Okay, that's a live on-site boot camp. Right here. So the week of February 19th. Notice how it says right here, it's the same color, but the CCIE Routing and Switching Boot Camp online. This will be the first time we've actually done this, where this will be for remote learners. So this is something you'll have to purchase. This is a standalone product. But if you purchase it, then for those 5 days, I will be giving my exact same CCNA classroom material, but it'll be in an online format. So like this, you'll see me online, you'll hear me online, you'll be able to interact with me. It won't be via YouTube. It's not going to be YouTube. It'll be a different interface. You'll be able to ask me questions. You'll have labs, so you'll be given a dedicated rack of equipment for use during those 5 days. And you'll have labs to do, and then you'll be able to ask me if you get stuck on the labs. We'll have quiz questions, so it'll be like the classroom environment except on your computer. So that'll be the first time that we've tried that at the CCNA level. So that'll be coming up. All right, so with that, I'm going to go ahead and end our class for today. I hope that this was enjoyable for you. I hope you learned a lot of good stuff. And I hope to see you again in one of my future classes. So have a good weekend, everyone. you.